everyone, welcome back to Learning at 11th hour. So, today we are going to look at some analysis methods. These methods are going to help us identify or compute parameters like the current and the voltage drop across different elements in a circuit, where the complexity of the circuit is more. So, before we go into the different techniques, we need to understand certain circuit terminologies. To begin with, the first one is we need to know what a branch really means. So I'll represent that with the letter B. So a branch here is any circuit element that is available in this circuit. So for example, this voltage source VA is a branch. This I'll call this as say A and this as B. So this uh, element RA between AB forms a branch and so on. So in that case here we can actually identify seven branches: one, two, three, four, five, six, and seven. The second terminology which we need to be familiar with is a node. So, a node is something that we've already discussed in one of our previous videos, and we know that there are two types of nodes: a simple node and a principal node. The number of nodes, if I assign the variable n to it, then we can identify the number of nodes here to be. So, this would be one node, I'll call it n1, because these are the two elements that are meeting. The voltage source and this resistance Ra are meeting at n1. Then we have n2 over here. This is n3. This node is going to be n4. And all of these branches are culminating at this point. And since there are no other elements in these wires, we can consider all of these to be the same node. So I'll call this as n5, which acts as the reference node. So therefore, the number of nodes n here is 5. The third parameter is number of individual loops. So a loop is basically a closed path which is available in the circuit. Now looking at this circuit, we can easily find out uh, that there are three loops over here. Visually, we can find out that there are three loops over here because there appear to be three closed paths. But when the complexity of the circuit increases, then it becomes difficult to find out the number of closed paths or the number of loops available in the circuit. So therefore, if I represent the number of individual loops by the variable L, then I can actually compute the number of individual loops L by the empirical formula B minus N plus 1. So here L becomes equal to 7 minus 5 plus 1 for this particular circuit, which is actually 3. So that actually matches our intuition. Having understood the various terminologies which might be required to understand the analysis methods, let us uh, directly go into the first analysis method, which is called as the branch current method. So, in this method, the branch current method, we would be assigning a current to each of the branches in the active network. After this, we will be applying the KCL at all the principal nodes. And we would be finding out the voltage across the nodes and consider some relationships to find out the unknown parameters. So, let's take this example problem here. So, we are going to consider the branch current I1 in the branch 5 ohms. We'll consider I2 to be in this direction in the branch 2 ohms and I3 in the 10 ohms branch. Now, if when we apply KCL at node A, so at node A, what do we get? So we know that I1 is incoming, so plus I1 minus I2 because it is going out of node A and minus I3 going out of node A is equal to 0. So we can say therefore that I1 is actually I2 plus I3. So this is my first equation. Now, if we consider the voltage across the terminals AB, so that would be VAB. And Applying Ohm's law, considering that B is my reference node and the reference being 0 volts, so I can say VAB is nothing but 10 into I3. So this is going to be my second equation. Now, if I want to compute VAB in terms of I1, then let's look at the voltage drops in this part of the circuit. So we have, let's mark the direction of the drops here in this manner. So here, if we consider this to be our drop direction that we are assuming, in that case, I can write the equation, KCL equation in this closed path as minus of 20, because the two arrows are opposing, plus 5I1. So that is going to be equal to my VAB. So this is going to be my third equation. In the same way, we can actually write the KVL equation in this half of the circuit or in this closed path. So let's mark the directions again from positive towards the negative, positive towards negative, and let's assume the direction to be in the direction of I2 itself. Now I can write the equation as, see, the assumed direction and the drop direction of this 8 volts is the same. So I can say plus 8, the direction of the arrow here and the drop across AB is opposing. So minus VAB and plus 2I2 is equal to 0. So this becomes my fourth equation. So here we can actually replace the value of VAB in terms of I3 as 10I3. So rewriting this equation, I'll actually get uh, minus 20 plus 5I1 is equal to 10I3. And rewriting this equation, I would get 8 plus 2I2 again is equal to 10I3. So we now have three equations. So this one being 1, this being the second, and this being the third. So we have three unknowns, I1, I2, and I3, and we have three equations to solve. So by using the matrix method, we can solve it, or we can solve it as simultaneous equations, and we can obtain the values of I1, I2, and I3. So we obtain the values of I1, I2, and I3 as I1 being equal to 2 amps, uh, I2 and I3 are equal to 1 amp each. So this is the branch current method. So here we have assumed the currents, different currents to be flowing through each of the branches, and applied the KVL and the KCL equations to find them out. The next method is the mesh current method. So here we need to identify the number of loops in the circuit and consider that we are going to have loop currents flowing through each of these loops. So with the help of these loop currents, we are going to find out the currents flowing through the different elements in the circuit. So in this circuit, we can actually identify the number of loops that are available. So here you have two loops. We could also verify that from the empirical formula L is equal to B minus N plus 1. So the number of branches here is 1, 2, 3, 4, 5. And the number of nodes here is 1, 2, 3, and 4. So n is 4. So we have 5 minus 4 plus 1, which is nothing but 2. So we have two individual loops over here. We can now consider two loop currents to be flowing through these two loops. Now the loop current's direction could be clockwise or anti-clockwise. Uh, it is not necessary that we have to consider both of them to be clockwise or both of them to be anti-clockwise. You can choose any arbitrary direction for the loop currents. So for the sake of simplicity and to ensure less amount of error in the way we approach a problem, let's just consider that we assume the loop current to be in the clockwise direction always. So in this case, we have loop current I1 flowing through loop 1 and I2 flowing through loop 2, both of them here assumed in the clockwise direction. The second step after assuming the loop currents is to apply KVL at each of these loops. So KVL at loop 1. Here we are going to apply KVL. So before we do that, we need to mark the directions of the voltage drops. So here we have the plus and minus. This would be the direction of drop here, and this will be the direction of drop here. So we need to remember that in this 10 ohm resistor, there are actually two currents flowing. One is the loop current I1 in this direction, and the other is the loop current I2 flowing from here in this direction. So this would be the a drop. So let me erase this arrow so that there's no confusion. Right. So this is the drop due to I1 and this one is the drop due to I2. So we need to consider that both the currents are flowing uh, into or out of this 10 ohm resistor. Now applying KVL at loop 1. So that would be minus 20 plus 5I1 plus 10 I1 minus I2. Why is that? Because we are now looking at loop 1. So I1 is the main current over here and I2 is opposing the I1 direction. So therefore, we are considering that the current flowing through the 10 ohm resistor overall is I1 minus I2. So sum of all of these voltage drops and rises is now going to be equal to 0. So simplifying this, we would be getting 15I1 minus 10I2 is 20. So that's the first loop equation. Now applying KVL at loop 2. So here we need to mark the drop directions. So this is plus and minus because the I2 loop current is entering here. This will be the drop in this direction and here it's already marked. So now we are considering the KVL equation from loop 2 point of view. So here we are going to have 8 because the direction we have assumed and the direction of drop across the 8-volt source is the same. So plus 8 plus 10 into I2 minus I1 because this time around we are considering the KVL from loop 2's point of view. So we are considering that the current flowing through the 10 ohm resistor is now I2 minus I1 and plus 2I2. All this put together is 0. So when we simplify this, we get the second KVL equation as minus 10 I1 plus 12 I2 is equal to minus 8. So this is going to be my second KVL equation. So on solving the two simultaneous equations, we get that the value of I1 is 2 amps and the value of I2 is 1 amp. So this is different from the branch current method in the sense that we are not considering different currents for each of the branches. We are now more concerned about the closed paths that are available in the circuit and we are finding out the circulating currents in these circuits, and with the help of that we are finding out the currents that are available or flowing in the different branch elements. So this method is also called as the circulating current method or loop current method or the mesh analysis. So that's all for today in this video. In the next video, I'll tell you how we can extend the concept that we used in mesh analysis to obtain the loop currents for a larger network with more than two loops. The example that we considered today just had two loops, but if there were more complicated circuits with more number of loops, then how are we to extend this concept? So that is what we'll be discussing in our next video. Hope this was helpful. Thanks for watching. Please do subscribe to my channel.